Hello, everyone. Apologies for the technical difficulties. Let's welcome to the stage Jacob Quinn, who will be leading this talk on modernizing JSON for Julia. Let's give some virtual claps to Jacob. And without further delay, Jacob.
Hey, thanks, Muriel, for the introduction. Yeah, I'm Jacob Quinn, software engineer. I currently work at a place called Christopherson Business Travel. We're working on a travel industry tech platform. I've been a long-time contributor to the Julia ecosystem, over 10 years, ever since it was kind of first publicly made available as a project. It's been a lot of fun. I've kind of contributed some to the core language, a lot to kind of core packages in the ecosystem, and it's somewhat of a hobby of mine to work on kind of fundamental, pieces of functionality in the ecosystem. So today we're going to talk about some of the work I've obsessed about, which is around how to do JSON in Julia. Let me switch over to my presentation tab here and we can talk through it. So JSON is interesting because it's everywhere. It's involved in a lot of things, and cross-language browsers, APIs. It's kind of become a ubiquitous standard for data transfer in the world, and it seems fairly simple, and it's meant to be human readable. And then there's actually all these pain points. It can get really complex, and then trying to navigate that complex JSON can be annoying. It's very simple in that it only has a few set of types you need to worry about, and yet we live in a world where we actually want type safety, and we want strict kind of guidelines in our applications around the, how the data is going to come across. And so how do we kind of craft modern libraries to handle this, to be convenient and simple, yet also powerful and flexible for those cases where we need it? A little bit of history of JSON and Julia. The original JSON package was written way, way early. I think it was even part of the core language at one point as an extension before there were actual packages in language. It quickly got moved out as one of the first packages that was ever published in Julia. It was very much based off of kind of other language patterns for dealing with Julia for JSON, and you can kind of see that in the code structure. And then it didn't really change for like 10 years. The core package just really stayed pretty much the same for a long time. It was decently performant, but very simple and didn't support kind of a lot of bells and whistles that you would expect. I've personally worked on a couple JSON packages that started with JSON 2 and then JSON 3. Those were my attempts at trying to provide additional typed parsing functionality and working through interfaces with JSON and Julia. There was another really interesting package that I took a lot of inspiration from called lazy JSON. And the idea there was it was a truly lazy package where everything was a lazy reference to some piece of JSON. It was a really interesting idea, and I think it had some interesting techniques. It was never really, really finished kind of the implementation, and so it was never really widely adopted, but it did inspire some of the ideas that go into what I'm going to share today. So JSON, I'm calling it the 1.0 release. This is kind of the, aggregation of all of the ideas and work and things that I kind of put into JSON and Julia over, probably a 7-8 year period of trying things out, experimentation, trying to get the right balance of performance and flexibility and power in what we want. So that's kind of what I'm going to share today. This is, kind of more examples of kind of what we'll be talking about. Trying to bring together, the strengths of Julia, multiple dispatch, zero cache abstractions, composable libraries, with performance, obviously, and then also, the right ergonomics. So making it feel very, very simple and easy to get started. And then when you need more complexity, everything is there under the hood to kind of leverage. The first part we're actually talking about is not JSON. It's a helper kind of package called struct utils. So this is a package that provides some of the traits interfaces over your Julia structs that make JSON really easy to operate with. So this is defining things like, is your struct, array-like? Is it dict-like? Is it not a struct? So there's a non-struct trait. And then also we define some really powerful domain transformation functions. And then also a very handy interface function called apply each, which is a way to kind of walk struct properties, key value pairs over your structs or dicts or whatever you're working with, that also supports early returning. And so we'll actually see this is one of the most powerful kind of interfaces that JSON is able to leverage to achieve everything that it needs to. For lower and lift, the idea here is that the entire idea of JSON is that it's a format, right? It's a data format that I need to get my data, which is in my Julia domain, into the JSON domain, right? And so the idea here is that lower and lift provide a way to do that transformation. I'm taking my Julia structs, my Julia data, I'm lowering it into the JSON domain. And so we can see that provides a really powerful interface where I can define how my Julia data, which may have arbitrary complexity and weirdness and extra hidden fields that I don't really want to care about in JSON, and then how do I define how that ends up serialized in JSON. And then the reverse as well. So the idea of taking JSON data, which is very simple and a fixed set of types, and saying, how can I lift this JSON data into my kind of more abstracted, more complex, more powerful Julia domain. And then also having these concepts specific for like keys in objects ends up being really useful, because sometimes you want to treat those specifically. Let's go over the other kind of core concepts of the JSON package with the new release. So everything is kind of built off of this core lazy value struct. So any entry point into JSON parsing, this is on the read side, it goes through this lazy value. So the idea is that we have some kind of underlying string, bytes, buffer, JSON data. We have a position in that data that we are interested in, and then we do a peek at what's at that byte position in the data, and we can figure out what kind of type of JSON is there. And that actually becomes really powerful. We can essentially base all other parsing needs off of that. And so I'll kind of show how this composes with everything else, but this actually has its own entry point, which is JSON.lazy. So you can feed any kind of JSON string, bytes, whatever, an IO buffer into JSON.lazy, and you'll get a lazy value back. What can you do with a lazy value? Well, this is where we have a useful module called the selectors module, and it allows lazily kind of walking parsing of the JSON that always returns another lazy value. And so think of this like a JSON-P implementation, or like XPath for XML. I can lazily navigate deeply nested structured JSON, and I'm not materializing anything. There's no allocations happening here. I'm literally just saying, go find a key that is called data in this JSON blob, go to the last element of an array, and then give me the timestamp key of that last element of the array. This is some syntax that's like a recursive. This is recurse through all levels of the JSON, and find me any key, any objects where or any values where the key is ID. And so this provides you some functionality, some like conditional function mapping to extract properties. So it becomes really, this becomes really powerful in terms of if I only need a tiny piece of a little, deeply nested JSON structure, I can extract that very precisely, no extra allocations, and it's very fast. So well, let's combine the two things we talked about: struct utils, apply each, plus the lazy value from JSON. What that gives us is the ability to walk JSON, and we can walk JSON values by their key value pairs, or their arrays by index, value pairs. And now that allows us to kind of do anything we want with lazy values, because we can walk them, and it makes it so we can do powerful things like constructing types, or do default parsing, or even on the right side, we're serializing Julia things into JSON. So let's talk about untyped parsing real quick. That's where I'm just, passing JSON to JSON parse, and then I'm getting something back, right? I'm not specifying what kind of type of Julia object I want back. And so JSON's going to provide you a default set of things that will return. This is new in the JSON 1.0 release, this JSON.object. It's a really useful custom object to the JSON library. It's essentially a drop-in replacement for a dict. It is mutable. It is supports all of the abstract dict interface. You can call has key. You can do get with a default. You can do get bang. You can do all of these things. But it's actually a more efficient representation than a dict. So a dict under the hood uses several arrays or memory buffers. JSON object is just a small linked list object of key value entries. And so for JSON, which tends to be a small number of key value pairs, it tends to not be thousands and thousands of keys, which you want to account for in a dict. It actually typically has very, very strong memory benefits compared to a dict. And then it's also faster in a lot of ways, because it's faster to construct this small little linked list of key value pairs than a full-blown dict. Some of the other nice properties it has is it preserves order, insertion order. So in particular for JSON, the order of keys in the JSON objects. Not critical, but it's a very nice to have. A lot of the times the JSON keys are meant to come in a specific order, and so preserving that is very convenient and nice. It also supports dot access, so you can say object.key to get any key that's inside that object. So there's a lot of niceness with this JSON object. For arrays, we return vector any, and then something that was really important to me in this iteration that we've never really had in any JSON Julia library is kind of full number support. It's kind of this weird part about the JSON spec for me. It's very loose in terms of how it defines numbers. It's not really IEEE. It's not really integers or floats or whatever. It's just kind of number, and you don't exactly have any bounds or restrictions on that. And so the JSON 1.0 release in Julia, it supports kind of progressively understanding what kind of number you're dealing with. So is it an int? Is it an integer? Are there no fractional parts? If not, we promote to a float 64. And then we also have spillover parsing to big int and big float. So when things get beyond the precision of an int 64, which is an 8-byte integer, or a float 64 8-byte float, we will promote, if you will, to big int big float. We will always parse exactly the number as it is in the JSON and be able to represent that faithfully. Moving on to typed parsing in JSON, this is where I want to provide the type that I want to get out. So I have some JSON, I want to parse it, but I want to get a Julia custom struct out of that instead of the default untyped parsing here. So there are some great defaults set up here. Most of the time, I'd say 95% of the time, you don't have to do anything. You can just pass in your custom struct here, and as long as it's relatively simple and not too crazy, we can just parse that. There's a lot of magic that goes under the hood. Obviously, we're using reflection on the type here to figure out the keys that are expected. we're matching those with keys that we find in the JSON. We're doing some automatic kind of union handling and being able to figure out nulls versus nothing and that kind of stuff in, mapping JSON to Julia. But for the most part, it just works, which is really nice. The struct utils package and JSON leverage some of these other struct utils annotations, so to kind of get into the more complex behavior. And so one of those is the defaults macro. This allows you to provide defaults on a plain struct to any field. So you can see here we're providing 0, anonymous, date 0 here as like the default values. If these keys are not found in the JSON, this is the value that will be used. So JSON is respecting this struct utils kind of annotation on your fields. And then struct utils also introduces this really helpful idea of field tags. So that's this syntax here. You start a field tag with this little ampersand here. And then specifically, I'm using the JSON key in my field tag to say that this, the key value name tuple here that comes after is specific for JSON related things. In this case, I'm providing a custom date format. Okay, so this field is a date. Normally, the dates formatted in Julia are ISO 84601, and so I'm saying actually when you parse this field in JSON, you're going to be looking for it in this format instead. So it'll be a JSON string. It'll be this format. I'm going to parse that string with this expected format to get my date in my Julia struct, right? So date is not a native JSON, idea or supported kind of data type. Dates are stored as strings, or maybe Unix timestamps, integers. And so in this case, I'm specifying how a JSON string value should be interpreted, lifted, if you will, into the Julia domain as a date by parsing it using this format. And again, this is the field tag syntax from struct utils, where we're leveraging that for JSON. So I don't have to do anything else to specify with this struct that this will be parsed. It just kind of automatically says, oh, I know about this field tag key. I'm looking for that. Dates are automatically supported with that. And now I know how to parse your person thing here. So yeah, we talked about field tags a little bit. The other big idea from struct utils is this idea of styles. And styles are a way in struct utils to essentially say, I have full control over how interfaces are defined over types, even when I don't own the type. I can create a custom style and then overload the interface for a given type, even if I don't own that. This is a big idea in Julia, right? This idea of type piracy. Julia is so composable, and multiple dispatch relies on dispatching on types so much that sometimes we get into this murky area where I say, actually, I need a slightly different behavior for this type in my use case. But if I don't own that type and I'm trying to overload the interface or the behavior for that type, I become a pirate, right? I don't own that. I'm kind of stealing that type and defining its behavior for everyone, or at least anyone in my session, and that can have bad effects, right? Because other parts of the package ecosystem are expecting different behavior or other default behavior that the type owner defined. Styles allows us to work around that by saying every interface in the struct utils or the JSON package can be overloaded for a given style that you own. That allows you the functionality to kind of get around that. It also allows us to specify a specific key that should be expected for field tags when we're parsing. So in this case, we have a custom JSON style that we're overlaying in the JSON library. And we're saying that field tags, we're looking for the JSON field tag. This doesn't conflict if anyone else wants to come along and also do a JSON. There's just that for the JSON library 1.0 release, when you have field tags, we will be looking for this key and we will respect things that are put in there. But it allows also, specifying a different name of, something I would see in the JSON, even though the name in my Julia struct is something different. So this extends to lift and lower. We kind of talked about that earlier, but it's a way to do the domain transformation. This is just a quick example of how we do that. So in this case, I'm not defining a struct in Julia. I'm actually defining something that I want to serialize as a JSON kind of primitive or an atom, right? This is a percent thing struct that I want to serialize to JSON as a float, not as a struct, that has a single key value pair value and value key with value. So I'm using this non-struct annotation to say this is not a struct. Don't serialize it as such. But in doing that, I need to then, explain how this goes down to the JSON domain. How do I get it back out? So we have lower here, which says, hey, take this percent, and you're actually just going to output it to JSON with the value. So I'm going to serialize it as a float64, as a number in JSON. And then when I'm lifting that back out, when that's coming from JSON, this will be a float64. I'm going to call percent over that float64. Okay, so even if this is parsed as an integer, I'm going to turn it to a float64. I'm going to construct a percent from it. So very easy transformation here, but it allows me to kind of define the behavior here. And if I wanted to customize that for a different style, I could do that. I could change the lowering, change the lifting. On the right side, we also support a lot of powerful concepts here. We are using these struct utils interfaces over your custom structs. So there's ability there where you can say omit things or ignore things, don't include this in the serialization, those kind of things, change the name as it gets serialized. We also have struct level annotations, omit null, omit empty, which control value or JSON null value. It will not be included when serialized. That can be really helpful because a lot of times we want really efficient ways to kind of serialize things going out. We don't want to include all these extra fields. We also have pretty printing and numeric controls, so I can control how numbers are outputted using these printf kind of concepts. And that's writing in Julia in the JSON library. Supports JSON lines. We support in-place parsing. So if you already have kind of an object that you keep around a lot and you want to kind of keep replacing things from JSON as you come in, this works a lot of times in like application services for config or other things. You can do this bang parse, parse bang, where I'm mutating this object as I parse it. Yeah, and that's about all of the things that I wanted to go through. It's really powerful. It's out there. It's published. A lot of packages in the ecosystem are switching over to it. Some of the things I'm thinking about next are, this is something I'm working on right now, is how do we make producing JSON schema really convenient? Maybe we relax some things and support something like JSON 5. I've played around with different SIMD level parsers. It can be hard to take code that's focused on SIMD and make that work in the nice composable kind of interfaces we provide, but I think there's some possibility to play around with there. And yeah, so that's JSON 1.0 release in Julia. So thanks for coming. I know we got started a little bit late, but I was hopefully didn't have to rush too much through there at the end, but I appreciate you coming through, and reach out to me on GitHub or you feel free to message me or try out the package and let me know how it goes. Thank you.